We've got 6 transformations to look at. In this first one, we're going to look at the effect of d on a function. So imagine I had the transformation where it says y is equal to f of x plus d. What's the effect of d? Well, I'm going to take my constant controller here, and I'm going to change this value from 0 to 1. And what's going to happen is I am going to change the y value. Since outside the function is going to change the y value. And if I change the d value to 2, I'm going to, basically what I'm going to do, I'm going to take the y value that I have now, and I'm going to add 2 to it. And so this point here, I'm going to predict is going to go up 2, is going to go through here. This point 2, this point here, the y value is 1. The point is 1, 2, so it'll go up 2. Negative 2, 2, add 2 to the y, it will go up to here. And so let's see as I make this value 2. Indeed, it shifted the whole graph up. So this is called a vertical translation by a factor of 2. Okay, so now let us return d to the beginning. And let us erase select all scribbles, and we'll try this. Now, the next one, we're going to look at the c value. We're going to look at, if I have a function y equals f of x minus c is how we usually write it. The reason why it's minus c is, well, when it's inside the function of f, it typically does something funny. In this case, what it's going to do, if I change the c value to a 1, in essence, what I'm going to do before I do that, I'm going to make sure I should change this to a negative c. Negative c. So, hold on. I don't want plus or minus. Let's just make it negative. Okay, so if I take my c value and I make it 1, in here it's going to be a negative 1. So I really have the function that says y is equal to absolute x minus 1. And so when I have a minus 1, I would think intuitively I would go this way, but what happens is the x value goes in the opposite direction. So this point here will go to the right 1. This point here will go to the right 1. I add to the x value. It's inside the function, so I add to the x. So I will add 1, which is opposite of what that says. This point here, I'm going to predict will go there. Same with the origin, it will go to here. And if I change this now to 1, it does indeed go through those 2 points. So this is called a horizontal translation by factor of 1. Even though it's negative, I am still going to the right 1, to the right 1. Horizontal translation. All right, let's close this. Let's look at the next transformations. Now, in this particular case, I'm going to look at the different transformations. This is my f of x. And I'm going to look at f negative x, which means as a value is going to become negative. And again, I am working on the outside of the function. So if it's outside, it is the y value that gets changed. So all my y values are going to become negative. So here's 1, 1. I'm going to get 1 multiplied by negative 1, and that changed this. This is 1, negative 1. Here we go. 1, negative 1. Change the y values, multiply by negative 2, 2 by negative 1, and I get down here. And so the graph 0, 0, the 0 of the y gets multiplied by negative 1, stays 0. And so when I change my a value to a negative 1, it does that. And so this one here is called a reflection over the x-axis. The y value has been affected, but it reflects over the x-axis. The outside of function means the affects the y. In this case, it's multiplied by negative 1. It's a reflection over the x-axis. Okay, let us try. Let's get all our scribbles. Delete those now. Let's go over to the b value. That is inside. That's this scenario here. If it's inside the function, I know it's going to affect the x value. So let's put a back to positive 1. There's our original function. And now I'm going to make the b value negative 1. And so I'm going to take the x values and I'm going to multiply them by a negative 1, which means here I'll get the x times negative 1 will get me negative 1. This will be negative 4, 2. And I predict the graph will go like this. Let's see what happens when I do it. And indeed, when b is negative 1, I can see it flips here. And this is called, when I have that, it's called a reflection over the y-axis. Okay, so when it's inside the function, it affects the x value. Outside the function, affects the y value. Okay, the last one, now we're going to look at this function here, and I'm going to look at a on the outside. So this is a function that looks like y is equal to a f of x. And I'm going to take this a value. It's outside the function, so I'm going to multiply the y value times a by factor a. So if I'm going to make a, let's say, 2, well, I'm going to take the y value and multiply by 2. 1 times 2 is 2. 2 times 2 is 4. This is the point here, 9, 3. 9. This 3 multiplied by 2 goes up to 6. And so if I double that, it'll be around here somewhere. So I'm doubling the y value. Let's see what happens here. My cost control is set up to go by 1. Let's see what happens when I change it to 2. It indeed goes up through here. Bad estimating there. So now, what happens now, if I take this value and I change my a, if I change my a to, let's say, 1/2. I just want that scribble to go away. See if I can get the scribble and move it. There it's go. All right. So if I'm going to change my a value now, let's change my a value to 1, let's say 1/4. Well, then my y value here, multiplied by 1/4, will be 1/4. Multiply 2 times 1/4. 2 times 1/4 is 1/2. 3 times 1/4 is 0.75 up here. And so if I change that to 0.25, I get that. It's called, this transformation is called a vertical stretch by a factor of a. Okay, it's outside the function, affect the y value. All right, and now we save the hardest one for last. Now we're going to change the b value here. And so this is a scenario that says y is equal to f of bx. This is inside the function, so it always does kind of opposite what you would expect. And it's the x value that is multiplied. So if I let b equal 2, we would typically expect multiply the x value by 2. This point here, which is 1, 1, we would multiply this by 2. But because it's inside the function, it acts differently. What we do is we divide by 2, or rather multiply by 1/2. So the x value gets multiplied by a half, which will make it 1/2, 1. This should be the point 1/2, 1. This point here, which is 4, 2, multiply the x value by a half. Half of 4 is 2, 2. This value here is 6, about 2.5. Well, multiply the x value by a half, and I get 3. It's going to be about here. 9, half of 9 will be 4.5, which will be about there. So if I make b, my b value 2, it should travel here. Let's make b 2. And it does. The x values all get multiplied by a half. Okay, so x value by a half means the b value is 2. All right, let's try another example here. Let's get all my scribbles and let's delete those. Okay, let's try the same scenario, except let's now, for my y equals f of bx, let's make b equal to 1/3. Now, as opposed to multiplying by a third, I'm going to multiply by 3, and this is the x value. So this point here will become 3, 1. This point here, which was originally 4, 2, the x value is multiplied by 3, will be 12, 2 out here. Well, 0, 0, multiply 0 by 3, and I stay 0, 0. Let's say 2. This is 2, 1.4 approximately. Multiply 2 times 3, and I get 6. So it will end up over here. This point here is the point 3. Well, multiply the x value by 3, and I get 9. So it should be about here. So let's change b to 1/3. 1 divide 3. And you can see it went through those points. The x, so multiply by that, it's the x values. So this here, in general, this is called a horizontal stretch. By a factor of 1/b. It's always the opposite, multiplied by the opposite. And those are our 6 transformations. We have a horizontal stretch. So let me just get a page here to talk about. So if I have a horizontal stretch, if I have the function here, y equals a f of x, f of b x minus c plus d. This here is the vertical stretch. A is the vertical stretch by a. B is a horizontal stretch by 1/b. The x value gets multiplied by 1/b. The y value gets multiplied by a. Because it's in, a is outside, b is inside the function. This is a translation to in c direction. So it seems like it's minus c, but because it's minus, it says it's going to go in c. And this is horizontal. Horizontal. The x value's changed. And finally, this d here is either up or down, a vertical translation. Vertical translation by d. Those are all our transformations. Oh, forgot to. If this is negative, it's a reflection over the y value changes, reflection over the x-axis. If the b is negative, it's a reflection over the y-axis. Reflection over x-axis, reflection over y-axis.